cyclic redundancy coding. Cyclic redundancy coding. Cyclic redundancy coding is a block code invented by Wesley Peterson in 1961. The cyclic redundancy checking is a block code invented by Wesley Peterson in 1961. It is commonly used to detect accident changes to accident changes to accident changes to accident changes to data transmitted via telecommunication networks and storage devices. It is commonly used to detect the accidental changes to the data transmitted via telecommunication networks and storage devices. It is commonly used to detect accidental changes to data transmitted via communication networks and storage devices. And this method is error correction and error detection method. CRC involved in binary division of data bits. CRC involves binary division of data bits being sent by a predetermined divisor agreed upon by the communicating system. The CRC involves binary division of the data bits being sent by predetermined divisor agreed upon by the communication system. The binary division of the data bits being sent by predetermined divisor agreed upon by the communicating system. The advisor is to generated by the divisor is generated using polynomial. The divisor is generated using polynomials. So CRC is also called polynomial code check. The divisor is generated using polynomials. So CRC method cyclic redundancy check is also called polynomial code checking. The CRC involves the binary division of the data bits being sent by predetermined divisor agreed upon by communicating system. The divisor is generated using polynomial. So CRC is also called polynomial code check. And this is the cyclic redundancy coding. And basically the block diagram is seen that a block diagram of this cyclic redundancy code. First we have to see that code segment, data segment. First we have to take the data segment and then you have to generate the CRC encoder and data segment, and next bit is going to the cyclic redundancy check by encoder, and each message data segment is called as the message bits, and plus CRC method is a CRC bit is cyclic redundancy bit CRC bit is the cyclic redundancy bit. The computer networks and use the CRC. All the used data is transmitting the message bits and CRC bit. Data segment plus CRC encoder. Encoder is a binary coded data. Is encoded the information by taking the message signal. Then message bits plus CRC is the cyclic redundancy code bits. Then after that CRC bit is connected to the computer networks. Computer networks is taking the more number of bits each added by the each bit is added each data bit is added to the CRC bit is added to this CRC bit is added to the cyclic redundancy code bit. After that is connected to the network, that is the computer network. Network is the basically two or more devices are connected. Two or more devices are connected, interconnected of the network is two or more devices to sharing the information that basically it is the data will be encoded, and in this fashion the data may be computer after transmitting the data may be corrupted, the corrupted the message signal corrupted the message signal. CRC is a cyclic redundancy decoder. After decoder and detecting the signal, after decoder and detecting the CRC cyclic redundancy code, after detecting the signal is depending upon the corrupted the message. If it is corrupted the message, the data may be losses. After that, what we have to transmitting the data, we have to receive the data at the data segment. That data segment is stored by the data bits. The data bit is stored by the data bit is corrupted and take as the CRC bit. Data segment is corrupted and networks data bit will be corrected. Two or more data will be another way to detecting the data from CRC method is data plus n divided by data at the transmitting end. The block diagram can explain in another fashion. The first is in data and plus n0 bits after it is given to the divisor. Divisor is divided, which bit is divided by the divisor division, and after divided is division by the data plus data bit plus message signal, and data plus n bits, and divisor is division by the divisor of the bit. After that divisor is division by the data bit. Divisor is divisor by the division of the bit divisor. After the divisor will be taking some reminder. The remainder will have to get a reminder. The remainder of the bit is taken either 0 or 1 reminder bit. After reminder we have to get the remainder is taken as the, if it is remainder is all the bit is 0, then the data may be there is no losses in the data, otherwise the data may be corrupted. If it is remainder is not 0, again we have to add it to the original data. That original data is will be added to the original data, then CRC decode original data. Then after that each message signal we have to add it to the CRC. After reminder is not 0, that bit will be acting as a redundancy code. That bit acting as a redundancy code bit. That bit acting as a redundancy code bit. The redundancy code bit that acting as a redundancy code bit. The redundancy code bit redundancy plus original data plus added to the CRC bit. Original data plus CRC bit. Original data plus CRC bit. that CRC bit is added to the code plus the CRC bit. Then after that transmitted through a cable and transmitted through a cable, again at the receiving end, that collecting of the data is CRC bit plus data segment. CRC bit plus data segment, again we have to collected the CRC bit plus data segment. Again we have to collected the data bit and collected the data bit and data segment. Again we have to division added after. If it is division number is 4, that we have to added the bit in case at the division the original data. If it is the redundancy bit is added n bit. If it is n minus 1 bit, if n bit, I will take the n minus 1 bit. If it is n bit is there, if it is n bit is there, n bit is there, if n is equal to n minus 1, if it is the data bit, original data bit plus CRC method, original data plus code original data. If it is divisor number, if it is 4, that we have to added the bit is 3 bit is added to the original data, 3 bit is added to the original data. That original data will be added, that is that taking the data bit plus n minus 1, the data bit plus n minus 1, the data bit plus n minus 1, the data bit plus n minus 1 bit, the data bit and n minus 1 bit, the original data bit, the data bit and the original data bit, the original data. Again reminder, if it is reminder, the reminder is taken as again. If it is original data added to the divisor n minus 1, all 0 bits added, then you have the division number. And including the, if it is non-zero bit, if it is non-zero at the reminder, then we have to take this again. Reminder bit is CRC bit, the CRC bit is added to the your original data and again division by the divisor. Then we have to simplify the binary addition and binary addition and exclusive OR gate, binary addition and exclusive OR gate. The binary data and exclusive OR gate is added. Then exclusive OR gate, that we have to simplify that data bit. The data bit is added to this data bit is original data bit added to the information bits plus CRC bit, cyclic redundancy check bits, message bits plus cyclic redundancy bit. If after that we have the reminder is again is original data plus reminder is added, we have to division by this number. After division by this number, we have to reminder, we have to get 0, then the data will be accepted at the receiving end, otherwise data will be rejected at the receiving end. The data will be accepted, the data bit is accepted, or the data bit is accepted or rejected. The data bit will be accepted or data bit will be rejected. Data bit will be accepted or rejected at the receiving end. Then after that corrupted the message bit and CRC decoder and data segment. This is the basic concept of this overall data. This is the basic block diagram to explanation of the CRC method. Then after that the cyclic redundancy coding, then we have to cyclic redundancy code, the encoding using CRC method. The polynomial, it will be taken as a polynomial data bit and encoding using CRC method. Encoding using the CRC method, cyclic redundancy coding. The communicating and parties agrees upon the size of the message. The communicating parties agreed upon the size of the message. Blocks of data plus CRC is a divisor number. Cyclic redundancy code divisor division and the number where take the blocks. Cyclic redundancy code CRC divisor and sending the blocks of data. For example, the blocks chosen may be the blocks chosen may be CRC method cyclic redundancy code 7, 4, where 7 is the total length of the block, and 4 is the number of bits in the data segment. The CRC cyclic redundancy coding 4, where 7 is the total length of the block, and 4 is the number of bits in the data segment. The divisor chosen may be 1011. The divisor chosen may be 1011. The sender The divisor chosen may be a 1011. The sender performs sending the data. It will be taken performs the binary division of data segment by the divisor. The sender performance binary division of the data segments by the divisor. The sender the performance binary division of the data segment by taken as a divisor. Will be taken as the divisor. Sender is performance binary division of the data segment by the divisor. Then the data divisor. The data may be divisor. The number performance binary division of the data segment by the divisor, and in it then appends the remainder. Remainder will be a reminder called CRC, cyclic redundancy code bits. To the ending of data segment. CRC bits to the end of the data segment. It then appended the reminder called CRC, cyclic redundancy code bit to the end of the data segment. This makes the resulting data until this makes the resulting data unit exactly divisible by the divisor. Divided by the divisor. Then after we have to take this divisor. We have to take the divisor CRC method. Then we have to encode it. That after at the receiving end we have to decode the signal. Decoding. The receiver divides the incoming data unit. The receiver divides the incoming data unit by the divisor. The receiver takes division by the whole data of the incoming bits. A lot of bits are coming from the input that can be divided into blocks. The unit by the divisor. unit data unit by the divisor. If there is no reminder, the data unit is assumed to be correct or accepted. If there is no reminder, the data unit is assumed to be corrected and is accepted. The receiver is divided. There is no reminder, the data unit is assumed to be corrected and is accepted. Otherwise it is understood that the data is corrupted. Otherwise it is understood that the data is corrupted. It is understood that the data is corrupted and is therefore after that the data may be rejected. Otherwise it is understood that the data is corrupted and is therefore after the data may be rejected. The receiver may be then send an erroneous acknowledgement back to the sender for retransmission back to the decoder. And after that next slides we have to move to the next slides. We have to go to the next slide here. Cyclic redundancy check. CRC method is an error detection method. CRC cyclic redundancy check. CRC is an error detection method. It is based on binary division principle. It is based on the binary division principle. How to generate this CRC bit? CRC bit is CRC cyclic redundancy coding. Cyclic redundancy code. CRC is cyclic redundancy code. CRC generator is an algebraic polynomial. Represented as a bit pattern. Bit pattern is obtained from the CRC generator using the following rules. Some rules are there for generating the algebraic polynomial represented as a bit pattern. Bit pattern is obtained from the CRC generator using following rules. And then after that we have to move to the next slide. Next slide is going to be CRC generator of the CRC method. Then we have to take this bit stream. The example of how to one example to solve this error detection by using the cyclic redundancy check. A bit stream is given. A bit stream is 110101111 is transmitted using the standard CRC method. The generated polynomial is x to the power of 4 plus x plus 1. The generated polynomial is x to the power of 4 plus x plus 1. What is the actual bit string transmitted? The generated of the polynomial is taken as g of x. It is a function of x. It changes the x value according to the polynomial will be varied. The generator polynomial g of x is equal to x to the power of 4 plus x plus 1 is encoded as 10011. double one. Clearly the generator polynomial consisting of a 5 bits. I have considered here 5 bits 11001. Consider as a clearly to generate the polynomial consisting of a 5 bits 10011. The polynomial generating the polynomial g of x. The clearly the generator polynomial consisting of 5 bits. So a string of 4 zeros is appended. So a string of 4 zeros is appended to the bit stream. A string, so the string of 4 zeros is appended to the bit stream to be transmitted. The resulting bit stream is if it is data for have to division by the number is 1 2 3 4 1 2 3 4 5, then the resulting bit stream is taken as 1101011011. Then we have to add the bit 0 is equal to 0000. 4 zeros we have to add it. This is the way we have to generating the polynomial division number plus 4 zeros are a string of the 4 zeros are appended to the bit stream to be a transmitted then after that bit stream will be transmitted. Then we have to take the example of the data bit. How to solve this example to error detection by using the CRC method, cyclic redundancy code. We have to see this one example here. I have to take this one example. Is reminder. The reminder take this data is equal to 11010 and 11011. The 5-bit data is taken here. 10 divisor is 10011 and dividend the original data is here. To add it to the data is equal to 4 zeros. The data will be added to the 4 zeros if your original data. Then we have to 10011 then we have to take the division by this number. It will be take by the one time it will be going to be one time is equal to 10011 will go to be a one time that is equal to 10011. Then we have to simplify this data bit. 10 is equal to here we have to take the exclusive OR operation. We have to consider as exclusive OR operation. Exclusive OR operation is equal to 0 plus 1. We have to add it 0 plus 1 is equal to 1. According to the exclusive OR operation, truth table is 0 0 is equal to output is 0 0 1 is equal to 1 1 0 is equal to 1 and 1 1 is equal to 0. Then we have to consider here one time. We have to take this one time will be going the one time should be going 10011 one time 10011. Then we have to consider as 1 0 is added to the 1 1 is equal to 0 0 is equal to 0 1 0 is equal to 1 at the 1 is equal to 0. If it is least significant bit MSB bit here, MSB bit is 0, that can be discarded. The 1 is equal to 0, this will be eliminated. This will be eliminated of the 0 bit, eliminated of the 0 bit, eliminated the 0 bit is 0 bit 110. This will be discarded. The remainder will be taken as the 10011. Again here the bit is 1, then will be divisor will be again goes to the 1 time. It will be again goes to the 1 time. It will be going to be 1 time. Then we have to 1 time bit is taken as 10011. Then we have to again we have to add it to the exclusive OR operation. Exclusive OR operation, that we have to next input data will be inserted to this reminder, that will be added, that bit will be going to be inserted here. The arrow mark is showing, the arrow mark shows, the arrow mark is showing, the arrow mark is here. We are inserted to the original data. Again 10011, again it goes to the 1 time. The 1 time will be going to the, again we have to 1 time, the divisor is equal to 10011. Then we have to add it to this 1 is equal to output is 0. The 1 is a 2 input, output is 0, and 0 is equal to 0, 0 is equal to 0. Then last bit is 1 is equal to 0. 1 is equal to 0. This bit will be discarded. This bit will be discarded at the 0. Then we have to next, after discarding the 0, after discarding the 0, again it will be added to the 0 times. It will be going to be 0 times. 0 into 1, 0 times it will be going to be 100. If it is 0 bit, again it will be 0 times. It will be take the 0 time, and 4 bits are added to 0 0 0 0. Then we have to add this bit is equal to 0, 1 0 is equal to 1, and 0 0 is equal to 0, 0 0 is equal to 0, 0 0 is equal to 0 plus 0 is equal to 0, 0 plus 0 is equal to 0, and at least significant again discarded. And next input data will be arrow mark. Next input data in the original will be 0, that will be added to insert here, that will be taken as 0. Then again 00010, again we have to get the 0 bit of the data, remainder is 0. Then again the divisor will be goes to the 0 times. 0 into 10011, that will be taken as 0 times. We have to consider here 0 0 0 0 0. Then again we have to add 1 plus 0 is equal to exclusive operation is equal to 1. 0 0 bit added to the 0, 1 plus 0 bit added to the 1, 0 plus 0 is added to the 0. This is the remaining we have to eliminate here. 0 1 0 1. Again we have to add it to the input. Again we have to add it to the input data. Again we have to add it to this input data here. Input data, again it will be 0 times. The 0 times, again we have to 0 0 0. Again we have to get 1 plus 0 is equal to 1, 1 plus 1 is equal to 1, and 0 0 is equal to 0, 1 plus 0 is equal to 1, and 0 0 is equal to 0. We had at least significant here, the bit will be discarded. The least bit will be discarded. After discarding this 0 bit, discarded the 0 bit, again we have to insert this. Again we have to insert the original data is 0 here. Original data is 0 here. Inserted to the 0. Original data will be inserted to the 0. Original data will be added to this your data, that will be taken as the data is equal to 10110. Again here 1 is the 1 is the LSB bit, MSB bit, and if it is starting position of 0 will be 1. Again the data will be going to be one time. It's going to be one time. The data will be going to be one time, 1 times into 1 time 10011, one time. That is the data will be inserted here. That 10011, the 10110, that is the data will be taken. 0 1 is equal to 1, 1 plus 1 is equal to 0, 1 plus 1 is equal to 0, 1 plus 0 is equal to 1, 0 plus 0 is equal to 0, 1 plus 1 is equal to 0. That least significant bit is, again we have to discard it here, 0 bit. Again we have to discard it the 0 bit. If it is the remainder is the what is the value of the remainder is 0101. The remainder is 010. Again the remainder is not 0. Again we have to division by this data by divisor. It will be the position of the MSB bit is 0. It will be going to the 0 times. 0 times of 10011, 0 time it will be going to be 0. That's all the bits are 0 0 0 0. Here 0 remainder is 0101, remainder is 0101. We have to add it to the data bit here 0. The data bit is 0. We have to insert it here 0. Then 10100. Then again the LSB bit is equal to 1. We have to get 1 times. It will be going to be 1 times of 10011. 1 times again we have to 10011. Then we have to add this data. The resultant we have to get remainder. 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. 0 plus 0 is equal to 0. 1 plus 1 is equal to 0. Here LSB bit, most significant bit with data will be 0, discarded. The remainder we have to get, the remainder is 0 0 11. The remainder is the remainder is 0. The remainder is 0111. The remainder is, have to get the resultant value of the remainder is 0111, 0111, 0111. Then the next we have to insert the next data is equal to here arrow mark here. We have to inserted here the data is 0. I have to get this previous image be discarded. I have the next bit of the remainder is 0 bit. That's why it is again going to the 0 times. 0 times of 10011. It will be going to the 0 times of 10011 times 0. Then we have to going to be a 0 0 0 0 0. Then we have to added this resultant value is 0 0 is equal to 0, 1 0 is equal to 1, 1 0 is equal to 1, 1 0 is equal to 1, 0 is equal to 0. We have to discard it. The remainder we have to get, the remainder is 1110. The remainder is 1110. Remainder is 111. Remainder is 1110. Remainder is 1110. 1110. The remainder is not 0. Again what we will do, again this data will be added to the original information. 4 zeros, the data again added to the 1110 to the original data. 1110 we have to add it to the data. Again we have to divide this division number. Then we have to remainder, that we have to get the remainder is, we have to get the remainder up to till we have to get the remainder is 0. Then the if it is remainder is not 0, the data cannot be accepted. The remainder is not 0, data cannot be accepted. Otherwise, again we have to what we will do at the receiving end. Again, this a reminder bit is added to the original data. Again, the original data, the data bit again added to the original data, and to simplify by this binary addition operation. We have to simplify the binary addition operation. Again, we have to add it to this binary addition operation. In this way, we have to add it to the binary data. After the binary data will be added to the binary addition of this binary data. Then after that simplification, if it is remainder is 0, the data will be accepted. What are the original information we have to transmit it at the transmitting end, and collecting at the receiving end we have to receiving the data. After that we have to this is the way we have to find out the CRC with the cyclic redundancy check. Then next slide we have to move. The next slide is going to be from here. CRC method is cyclic redundancy check. Cyclic redundancy check is known as cyclic redundancy check. Cyclic redundancy check is now the code word. Now the code word to be transmitted. The code word to be transmitted is obtained by replacing the last four obtaining by replacing the last four zeros, last for the code word, the information, the code word to be transmitted and get obtained. We have to collecting the data bit. We have to collecting the data bit. We have to collecting the data bit to obtain by replacing obtained by replacing the last four zeros, four zeros of 110101111. Then we have to four zeros are added. CRC bit is 1110, that we have to add it to the 0000. Thus the code word transmitted to the receiver. Thus the code word is transmitted to the receiver. The code word is transmitted to the receiver. The code word is transmitted to the receiver. This is the way we have to transmitting the data bit. This is the way we have to transmitting and recollection of the data bit. Now code word to be transmitted to obtain by replacing of the least significant bit. And these are the CRC method. There is some advantages. The advantages of these slides. The advantages of CRC method. Advantages of CRC method. Advantages of CRC. It is having the 99.99% of data may be the error 99% error or error may be detected. Error may be DETECTED. Error may be 100% of data may be detected. 100% of data may be detected. 100% data may be detected. 100% of the data will be detected. 100% of data may be detected. And next 100% of data will be detected. 100% is data may be detected. That data may be detected here. 100% of the data may be detected. 100% of data will be detected. Then after this is can check CRC can check the burst error, can check the burst error in the data. Or burst error, we can also check the burst error in this. We can also check the burst error in this.
मम्मी से बहुत बड़ा है। मम्मा कौन है? मम्मा कौन है? ओ बेर गई। कहाँ है तुम्हारी?
Here 99% of error may be detected. And second point, CRC can check burst error, and CRC is used for binary division. These all are the most advantages of binary division operation.